NEC 210.8 addresses receptacles in damp or wet locations. Receptacles installed in a wet or damp location that are not part of a luminaire, appliance, or cord set assembly must be listed as weatherproof and shall be provided with ground fault circuit interrupter protection. Firstly, let's clarify the term weatherproof. The receptacle must be designed to withstand the effects of rain, snow, ice, and other outdoor conditions. Secondly, let's talk about ground fault circuit interrupter protection. A ground fault circuit interrupter device provides protection against electrical shock by interrupting power when an imbalance is detected between incoming and outgoing current. Based on this code section, all outdoor receptacles must have ground fault circuit interrupter protection unless they are part of a luminaire, appliance, or cord set assembly. This rule applies regardless of whether the receptacle is readily accessible or not. The reasoning behind this requirement is that the presence of moisture in outdoor environments increases the risk of electrical shock. Ground fault circuit interrupter protection helps prevent shock by quickly shutting off power when a short circuit or ground fault occurs. This is especially important for outdoor receptacles that are used for powering appliances or tools. However, there are a few exceptions to the rule that outdoor receptacles must have ground fault circuit interrupter protection. These exceptions include luminaires, appliances, cord set assemblies, and receptacles that are supplied by a transformer with an isolated secondary winding. In conclusion, all outdoor receptacles, except for those listed in the exceptions, require ground fault circuit interrupter protection. This rule is in place to enhance safety and prevent electrical shock in outdoor environments. The 2017 National Electrical Code, or NEC, Section 210.8 covers ground fault circuit interrupter protection for personnel. Specifically, 210.8 focuses on receptacles in damp or wet locations. This section mandates that receptacles installed in wet or damp locations must have ground fault circuit interrupter protection. This requirement applies regardless of whether the receptacle is readily accessible. The code defines a wet location as an area subject to saturation with water or other liquids, and unprotected locations exposed to weather. A damp location is defined as a partially protected location under canopies, marquees, roofed open porches, unlike locations, and interior locations subject to moderate degrees of moisture, such as some basements, some barns, and cold storage warehouses. The ground fault circuit interrupter protection is intended to protect people from electrical shock. A ground fault circuit interrupter device monitors the current flowing in a circuit. If it detects an imbalance which indicates that current is leaking to ground, it quickly shuts off the power. This prevents a potentially fatal electrical shock. The weatherproof requirement ensures that the receptacle can withstand the elements, preventing water from entering and causing a short circuit or corrosion. Weatherproof enclosures are typically made of durable materials such as metal or plastic and are designed to be watertight. It is important to note that the term weatherproof is not interchangeable with waterproof. Weatherproof means that the enclosure can protect the receptacle from rain, snow, and ice, but it may not be able to withstand submersion in water. There are exceptions to the ground fault circuit interrupter protection requirement for outdoor receptacles. Firstly, luminaires do not require ground fault circuit interrupter protection. Luminaires are lighting fixtures that are permanently installed and are not intended to be moved around. Secondly, appliances do not require ground fault circuit interrupter protection. Appliances are electrical devices that are used for specific tasks such as cooking or cleaning. Thirdly, cord set assemblies do not require ground fault circuit interrupter protection. Cord set assemblies are power cords that are used to connect appliances to receptacles. Lastly, receptacles that are supplied by a transformer with an isolated secondary winding do not require ground fault circuit interrupter protection. An isolated secondary winding is a type of transformer winding that is electrically isolated from the primary winding. This isolation prevents ground faults from occurring. It is important to note that even if an outdoor receptacle is not required to have ground fault circuit interrupter protection, it is still good practice to install a ground fault circuit interrupter receptacle for added safety. Ground fault circuit interrupter receptacles are relatively inexpensive and easy to install. They can provide a significant level of protection against electrical shock. When installing outdoor receptacles, it is important to follow all applicable codes and regulations. This includes using weatherproof enclosures, providing ground fault circuit interrupter protection when required, and properly grounding the receptacle. It is also important to use the correct type of wiring for outdoor applications. Outdoor wiring must be rated for wet locations and must be protected from physical damage. In addition to the NEC requirements, local codes may also have specific requirements for outdoor receptacles. It is important to check with your local building department to ensure that your installation meets all applicable requirements. Improperly installed outdoor receptacles can be a safety hazard. They can cause electrical shock, fires, and other problems. It is important to hire a qualified electrician to install outdoor receptacles. A qualified electrician will have the knowledge and experience to install the receptacles safely and correctly. In summary, NEC 210.8 A3 requires ground fault circuit interrupter protection for receptacles installed in wet or damp locations. This requirement is intended to protect people from electrical shock. There are a few exceptions to the requirement, but it is always good practice to install a ground fault circuit interrupter receptacle for added safety. When installing outdoor receptacles, it is important to follow all applicable codes and regulations and to hire a qualified electrician. Understanding the National Electrical Code, or NEC, requirements for outdoor receptacles is crucial for ensuring electrical safety. Section 210.8 specifically addresses ground fault circuit interrupter protection for personnel in dwelling units. Subsection 3 hones in on receptacles installed in damp or wet locations. Let's break down the key aspects of this code requirement. The primary mandate is that receptacles installed in damp or wet locations must be equipped with ground fault circuit interrupter protection. This applies to all 125 volt, 15 ampere and 20 ampere receptacles installed in such locations. The NEC defines damp location as an area protected from weather and not subject to saturation with water or other liquids but subject to moderate degrees of moisture. Examples include under canopies, in roofed open porches, and in some basements. A wet location is defined as an area subject to saturation with water or other liquids such as unprotected areas exposed to weather. The ground fault circuit interrupter is a crucial safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing through a circuit. If it detects an imbalance, indicating that current is leaking to ground, the ground fault circuit interrupter quickly trips, cutting off the power supply. This rapid interruption prevents dangerous electrical shocks. The code mandates ground fault circuit interrupter protection in these locations because the presence of moisture significantly increases the risk of electrical shock. Water is an excellent conductor of electricity, and even a small amount of moisture can create a path for current to flow through a person's body. The ground fault circuit interrupter provides a critical layer of protection in these hazardous environments. It's important to distinguish between ground fault circuit interrupter protection and standard circuit breakers. While circuit breakers protect against overloads and short circuits, they do not provide the same level of protection against electrical shock. Circuit breakers typically trip at currents of 15 or 20 amps, while ground fault circuit interrupters trip at currents as low as 5 milliamperes. This lower tripping threshold is crucial for preventing electrical shock. The NEC also requires that receptacles installed in damp or wet locations be listed as weatherproof. This means that the receptacle and its enclosure must be designed to withstand exposure to the elements, including rain, snow, and ice. Weatherproof receptacles and enclosures are typically made of durable materials such as metal or plastic and are designed to prevent water from entering and causing corrosion or electrical hazards. It's essential to use the correct type of weatherproof enclosure for the specific application. There are different types of enclosures designed for different levels of exposure. For example, an enclosure designed for use in a wet location will provide greater protection than an enclosure designed for use in a damp location. While the NEC provides clear guidelines for ground fault circuit interrupter protection in damp and wet locations, there can be situations where the application of the code is not straightforward. In these cases, it's always best to consult with a qualified electrical inspector or engineer to ensure that the installation meets all applicable requirements. When installing outdoor receptacles, it's crucial to follow all manufacturers' instructions and to use appropriate wiring methods. Outdoor wiring must be rated for wet locations and must be protected from physical damage. It's also important to ensure that the receptacle is properly grounded to provide a safe path for fault current to flow back to the source. Regular testing of ground fault circuit interrupter receptacles is essential to ensure that they are functioning properly. Ground fault circuit interrupters should be tested monthly by pressing the test button on the receptacle. If the ground fault circuit interrupter does not trip, it should be replaced immediately. In addition to the NEC requirements, local codes may also have specific requirements for outdoor receptacles. It's important to check with your local building department to ensure that your installation meets all applicable requirements. In conclusion, NEC 210.8 A3 mandates ground fault circuit interrupter protection for receptacles installed in damp or wet locations. This requirement is crucial for preventing electrical shock and ensuring electrical safety in these hazardous environments. By understanding and following the NEC guidelines, you can help protect yourself and others from the dangers of electricity. Let's dive deeper into the technical aspects of ground fault circuit interrupter or GFCI protection as it relates to outdoor receptacles and NEC section 210.8 A3. We'll explore the operational principles of GFCIs, the different types available, installation considerations, and common troubleshooting scenarios. Firstly, understanding the operational principles of a ground fault circuit interrupter is essential. A ground fault circuit interrupter works by monitoring the current flowing in the hot, or ungrounded, conductor and the neutral, or grounded, conductor of a circuit. In a properly functioning circuit, the current flowing through these two conductors should be equal. However, if a ground fault occurs, meaning that current is leaking to ground through an unintended path, an imbalance will be created between the current in the hot and neutral conductors. The ground fault circuit interrupter detects this imbalance and quickly trips, interrupting the flow of electricity. The tripping threshold for a ground fault circuit interrupter is typically 5 mA, meaning that it will trip if it detects a current imbalance of 5/1000ths of an amp or more. This low tripping threshold is crucial for preventing electrical shock, as even a small amount of current flowing through the body can be dangerous. Secondly, different types of ground fault circuit interrupters exist, each designed for specific applications. The two most common types are receptacle type ground fault circuit interrupters and circuit breaker type ground fault circuit interrupters. Receptacle type ground fault circuit interrupters are installed directly into the electrical outlet box and protect only the receptacles on that particular circuit. They are relatively easy to install and are a good option for retrofitting existing installations. Circuit breaker type ground fault circuit interrupters are installed in the electrical panel and protect the entire circuit. They are more expensive than receptacle type ground fault circuit interrupters, but they provide broader protection. Another type of ground fault circuit interrupter is the portable ground fault circuit interrupter, which is typically used for temporary installations or for protecting equipment that is plugged into a standard receptacle. Portable ground fault circuit interrupters are commonly used on construction sites and in other outdoor settings. Thirdly, installation considerations for ground fault circuit interrupters are crucial for ensuring proper operation and safety. When installing a ground fault circuit interrupter receptacle, it is important to follow the manufacturer's instructions carefully. The ground fault circuit interrupter must be properly wired and grounded to function correctly. It is also important to ensure that the receptacle box is weatherproof if it is installed in a damp or wet location. When installing a circuit breaker type ground fault circuit interrupter, it is important to turn off the power to the circuit before beginning work. The circuit breaker must be properly sized for the circuit and must be installed in accordance with the NEC. Fourthly, common troubleshooting scenarios for ground fault circuit interrupters often involve nuisance tripping. Nuisance tripping occurs when the ground fault circuit interrupter trips even though there is no actual ground fault. This can be caused by a variety of factors, including moisture, loose wiring, or faulty appliances. To troubleshoot nuisance tripping, first try resetting the ground fault circuit interrupter. If it trips again immediately, disconnect any appliances that are plugged into the circuit. If the ground fault circuit interrupter still trips, there may be a problem with the wiring or the ground fault circuit interrupter itself. In this case, it is best to consult with a qualified electrician. Another common problem with ground fault circuit interrupters is that they can fail over time. Ground fault circuit interrupters should be tested monthly to ensure that they are functioning properly. If a ground fault circuit interrupter fails to trip when tested, it should be replaced immediately. In addition to the technical aspects of ground fault circuit interrupters, it is also important to consider the practical implications of NEC Section 210.8A3. This code section has a significant impact on the design and installation of electrical systems in outdoor settings. It is important for electricians and electrical contractors to be familiar with this code section and to ensure that all outdoor receptacles are properly protected with ground fault circuit interrupters. The cost of installing ground fault circuit interrupters is relatively low compared to the potential cost of an electrical shock. Ground fault circuit interrupters are a critical safety device that can save lives. By understanding the technical aspects of ground fault circuit interrupters and the requirements of NEC Section 210.8A3, you can help ensure that electrical systems in outdoor settings are safe and reliable. Furthermore, let's delve into some specific examples and scenarios related to ground fault circuit interrupter protection for outdoor receptacles. These examples will help to illustrate the practical application of NEC Section 210.8A3 and will provide a better understanding of the code requirements. Example 1. A homeowner is installing a new outdoor receptacle on their patio for use with power tools and other equipment. Because the receptacle is located in a damp location, it must be protected by a ground fault circuit interrupter. The homeowner can either install a receptacle-type ground fault circuit interrupter or a circuit breaker-type ground fault circuit interrupter. They choose to install a receptacle-type ground fault circuit interrupter because it is easier and less expensive. Example 2. A commercial building owner is installing new outdoor receptacles on the exterior of their building for use with holiday lighting and other decorations. Because the receptacles are located in a wet location, they must be protected by a ground fault circuit interrupter. The building owner chooses to install circuit breaker type ground fault circuit interrupters because they provide broader protection and are more durable. Example 3. A construction site is using portable ground fault circuit interrupters to protect workers from electrical shock. The portable ground fault circuit interrupters are plugged into standard receptacles and protect any equipment that is plugged into them. This helps to ensure that the construction site is safe for workers. Example 4. A homeowner is experiencing nuisance tripping with their outdoor ground fault circuit interrupter. They try resetting the ground fault circuit interrupter, but it trips again immediately. They disconnect all appliances that are plugged into the circuit, but the ground fault circuit interrupter still trips. They suspect that there may be a problem with the wiring or the ground fault circuit interrupter itself. They call a qualified electrician to inspect the wiring and the ground fault circuit interrupter. The electrician finds that there is a loose wire in the receptacle box. They fix the loose wire and the ground fault circuit interrupter stops tripping. Example 5. A homeowner is testing their outdoor ground fault circuit interrupter and it fails to trip when tested. They replace the ground fault circuit interrupter immediately to ensure that they are protected from electrical shock. These examples illustrate the importance of ground fault circuit interrupter protection for outdoor receptacles and the practical application of NEC Section 210.8A3. By understanding these code requirements and following proper installation and troubleshooting procedures, you can help to ensure that electrical systems in outdoor settings are safe and reliable. To further clarify the application of NEC 210.8A3, let's consider some frequently asked questions regarding ground fault circuit interrupter protection for outdoor receptacles. Question 1. Do all outdoor receptacles require ground fault circuit interrupter protection? Answer: yes, with some exceptions. All 125 volt, 15 ampere and 20 ampere receptacles installed in damp or wet locations must be protected by a ground fault circuit interrupter. The exceptions include receptacles that are part of a luminaire appliance or cord set assembly, and receptacles that are supplied by a transformer with an isolated secondary winding. Question 2. What is the difference between a damp location and a wet location? Answer. A damp location is an area protected from weather and not subject to saturation with water or other liquids, but subject to moderate degrees of moisture. A wet location is an area subject to saturation with water or other liquids, such as unprotected areas exposed to weather. Question 3. What is a ground fault circuit interrupter? Answer. A ground fault circuit interrupter is a safety device that protects people from electrical shock. It works by monitoring the current flowing in a circuit. If it detects an imbalance, indicating that current is leaking to ground, the ground fault circuit interrupter quickly trips, cutting off the power supply. Question 4. How often should ground fault circuit interrupters be tested? Answer. Ground fault circuit interrupters should be tested monthly by pressing the test button on the receptacle. If the ground fault circuit interrupter does not trip, it should be replaced immediately. Question 5. What should I do if my ground fault circuit interrupter is tripping frequently? Answer. If your ground fault circuit interrupter is tripping frequently, first try resetting the ground fault circuit interrupter. If it trips again immediately, disconnect any appliances that are plugged into the circuit. If the ground fault circuit interrupter still trips, there may be a problem with the wiring or the ground fault circuit interrupter itself. In this case, it is best to consult with a qualified electrician. Question 6. Can I install a ground fault circuit interrupter myself? Answer. While it is possible to install a ground fault circuit interrupter yourself, it is recommended that you hire a qualified electrician to do the work. This will ensure that the ground fault circuit interrupter is properly installed and that your electrical system is safe. Question 7. What are the benefits of installing ground fault circuit interrupters? Answer. The benefits of installing ground fault circuit interrupters include protection from electrical shock, reduced risk of electrical fires, and increased safety for your family and property. These frequently asked questions provide further clarification on the requirements and benefits of ground fault circuit interrupter protection for outdoor receptacles. By understanding these concepts, you can help to ensure that your electrical systems are safe and compliant with the NEC. To provide even more context, let's consider the historical perspective of ground fault circuit interrupter requirements in the National Electrical Code. The introduction of ground fault circuit interrupter protection into the NEC was a gradual process, driven by the increasing awareness of the dangers of electrical shock, particularly in wet and damp locations. In the early days of electrical systems, there was little emphasis on ground fault protection. Electrical codes primarily focused on preventing overloads and short circuits, with limited attention given to the risks of electrical shock from ground faults. As electrical systems became more prevalent and the use of electricity in homes and businesses increased, the number of electrical shock incidents also rose. This led to growing concerns about electrical safety and the need for better protection against ground faults. In the 1960s, the first ground fault circuit interrupters began to appear on the market. These early ground fault circuit interrupters were relatively expensive and bulky, and they were not widely adopted. However, they demonstrated the potential for this technology to prevent electrical shocks. In the 1971 NEC, the first requirements for ground fault circuit interrupter protection were introduced. These initial requirements were limited in scope, primarily focusing on swimming pool areas, where the risk of electrical shock was particularly high. Over the years, the NEC has gradually expanded the requirements for ground fault circuit interrupter protection to include other locations where the risk of electrical shock is significant. This expansion has been driven by ongoing research, data analysis, and the development of more affordable and reliable ground fault circuit interrupter technology. The 1975 NEC added requirements for ground fault circuit interrupter protection in bathrooms of dwelling units. The 1987 NEC expanded the requirements to include all 125 volt, 15 ampere and 20 ampere receptacles in bathrooms of dwelling units. The 1990 NEC added requirements for ground fault circuit interrupter protection in kitchens of dwelling units, specifically for receptacles serving countertop surfaces. The 1996 NEC expanded the requirements to include all 125-volt, 15A and 20A receptacles in kitchens of dwelling units that serve countertop surfaces. The 1999 NEC added requirements for ground fault circuit interrupter protection for outdoor receptacles in dwelling units. This was a significant step forward in protecting people from electrical shock in outdoor settings. The 2005 NEC expanded the requirements for ground fault circuit interrupter protection to include all 125-volt, 15A and 20A receptacles in damp or wet locations. This included outdoor receptacles, as well as receptacles in other areas where moisture is present, such as laundry rooms and unfinished basements. The 2008 NEC further clarified the requirements for ground fault circuit interrupter protection, making it easier for electricians and inspectors to understand and apply the code. The 2011, 2014, and 2017 NEC editions have continued to refine and expand the ground fault circuit interrupter protection requirements, incorporating new technologies and addressing emerging safety concerns. The historical evolution of ground fault circuit interrupter requirements in the NEC demonstrates the ongoing commitment to improving electrical safety and protecting people from electrical shock. As technology advances and new risks are identified, the NEC will continue to adapt and evolve to ensure that electrical systems are safe and reliable.